these equations, there's no KCL. Two components, three equations. So ID is equal to Kn for W for M1, this transistor is 1, 2, 3, would be K prime divided by 2 W over L of 1, whatever that is, times V GS1 minus 0.6 to the power of 2. These, you have values for them. You're going to put in the values. IG for the transistor number 2 is K prime. It's the same K prime. W over L2 VGS2 minus 0.6, the same DT. Power of 2. ID is equal to K prime over 2 over L3 VGS3 6 power 2. Then there are a couple more equations that you can write because you don't have VGS values labeled in this circuit, so you have to figure out what these VGS values are for this circuit. So VGS1, these are really not equations, these are facts more than anything else. These are equations. You're just writing facts here. These are knowns. VG1 minus VS1. And then this circuit VG is 9 volts. And VS1 is V2. And VGS2 is VG2 minus VS2. So VG2 is V2. And VS2 is 1. And VGS1 is VG1 minus VS1. G1 is V1. And VS1. Oh, I went S3. Well, sorry, that was true. Minus 0. So, given that, you have 1, 2, 3 unknowns and 3 equations. There are many different ways you can solve the 3 equation, set up 3 unknowns, 3 equations. Just pick one. So you can turn this into 2 equations by getting rid of ID. So you can equate these 2 and these 2, and then you get rid of ID. What?
Can you square it, like when you're solving by hand, can you square root it? Which one do you pick, like the plus or minus of it? Because there's 2 answers, right? You're plugging
What
in
that
things,
makes sense.
like, what
You have to make sure it makes sense. Now,
how do you know
what
that?
does make sense? You have 0 and 9 here. So anything that goes outside this bound is like if you get a negative number, immediately you know that's wrong. Because the voltages here, they add to 0 and they become ultimately 9. Everything has to be between 0 and 9. So any negative number is out of the picture.
But there's like a lot of different answers you can get depending on which one you start off with. So if you start off with the wrong, because I mean there's two square roots here for this one. You said there's going to be 2 equations. So when you
So let's try one of them. How about that? So someone who has 100, give me the year.
I got the first one,
Okay. So
if you want to see it.
numbers.
Oh, wait, no, you won't.
You don't have the numbers.
I have the numbers for the first one.
power 2, that becomes 0.0954 V2 minus V1 minus 6 to the power 2 becomes 0.12 6 to the power 2 plus these 2 and so from that 0.0954 V2 minus V1 0.6 equal to 2214 0.6. So let's take the square root of both sides and tell me the values quickly. There's going to be something V2 minus V1 minus 0.6 is equal to something 1.31 and something times V1 minus 0.6. That would be what? 0.47. Yeah, this is one of the answers, right?
So the left side could be
Then the other one could be, so the other option would be 0.31 V2 minus V1 0.6 is equal to minus V1 minus 0.6. Right? This would be the other option.
negative and positive.
It's the same thing.
Because you square root both sides. And you,
Yeah, I mean it's the same thing. You have two options.
I see what you're saying. Doesn't matter where the negative is. Even if there's negative on both sides.
Yes, negative on both sides is the same as positive on both sides.
Okay.
So now you just pick one and you go to the next and then you quickly get an answer.
Okay, I didn't realize the whole.
Okay.
Yeah.
Option 1, option 2. So roughly how long? 10 minutes. Doing it all the way. Okay, next. Number 2 was the easiest of all three. I was the one that I wanted you all to get a lot of points out of it, and on average, a lot of you are close. Okay, so it says, I wanted you to do this model and say, okay, this is the input resistance, this is the gain, open circuit gain, and that's the output resistance.
Would that be a current source or voltage?
There's a voltage source. I wanted you to calculate Ri, R out, and naught first. So this is your amplifier. Some of you still don't realize that this is your amplifier. That's not part of your amplifier. This is not part of your amplifier. How do you know that? Because of this L thing that it's there. It says load. load is not part of the amplifier. Load is what you connect to your amplifier. Okay? And this is not part of your amplifier, this is your input. This is your input, that's where your load or amplifier is going to get connected. Okay, so therefore when I say model for the amplifier, are you timing me? Yeah. Okay. So when I say model for the amplifier, this is your Ri, this is your R out. Whatever comes behind is not part of your amplifier. Whatever is over there is not part of your amplifier. So when you model that, those are not connected. So now you're looking into this, and a lot of you got R in and R out wrong, which, if you're asking me, is the easiest thing to do. But at least Ri is the easiest thing to do. You look into this, and you're looking for what resistance do you see. Basically, that's what you're an ohm meter, and you get connected to this node, and you want to know what resistance there is. What's the resistance looking into the gate? It's infinite. There's no current, so resistance is infinite. So there's an infinite parallel with 500K. So what is that?
500K.
500K. That's it. So Ri is 500K. If you don't have that right, there is something to be said about you not listening to me. Like, you just have to do some soul searching, see what's going on. You just have to figure out why this is not sticking. Okay? Okay, that's the easy part. Now, for the output, you have to do a small signal before you can actually, even for this part, you could have done this small signal, because that model is a small signal model of this thing. So in general, it would be wise to first turn your circuit into a small signal model and then calculate these things. For the input, it didn't matter because this is an open, so it doesn't matter. It is for the DC circuit or the small signal model. For both cases, that's an open, so that's not going to change. But for the output, it does matter, and therefore it would just be wise when you want to calculate those to first turn everything into a small signal model. Okay. So a small signal model. What do we know about the small signal model? Some of you saying, I don't know how to model a PMOS. It's exactly the same. There's no difference. You can keep everything the same and say this is GMVGS, and that's VGS, and that's the gate, this is drain, this is source. Or you can flip this and say GMVSG. Doesn't matter. Okay, up to you. And then there is a resistor. Because I have a lambda value, there's a resistor or not there too. So therefore, for me to know what this small signal model is, what do I need to know?
The current.
What's unknown here in this model?
GM.
There's GM and there's R naught. There are equations for those two, right? So the equation for